Okay, we're back to Math 200. We're looking at the notes for Chapter 6. This is 6.2. We're adding up variables with lots of fractions with lots of variables all over the place. And so we have like denominators. They're already common denominators. So all we have to do here, 2p plus 7 on the bottom, and then 4p plus 3p is 7p, and negative 3 and 8 is plus 5. And that's it for that one. That was a pretty easy problem to start with. So when they have like denominators already, it's kind of easy. Let's take a look though. Of course they're not going to leave it easy. 8y minus 16 over y minus 2. So we can't add the y and the 16, but what we can do is factor the top, factor out an 8, and then we're left with a y minus 2, and there's a y minus 2 on the bottom, and so now those will cancel. And so that ends up just being 8. Same thing with this. 3y minus 6 on the top. On the bottom, we can factor that. That is factorable. And so multiplies to be negative 10. It's the exact same thing twice. So multiplies to be negative 10, negative 1 and 10, negative 10 and 1, negative 2 and 5, negative 5 and 2. It's got to be this one. Y minus 2, y plus 5. So we have that on the bottom, y minus 2, y plus 5. And on the top, we could factor out a 3. And that'll give us a y minus 2. And so now we've got this. 3y minus 2 on top, y minus 2, y plus 5 on the bottom. Those y minus 2's cancel. We end up with just 3 over y plus 5. All right. Well, let's look at the next set of problems. Page 6 of the note packet. So now they're going to have us find the LCD. They don't want us to actually add or subtract them, but that's what is leading up to. So right now we have 1 over 6y, and we have 3x over 4y plus 12. So find the LCD of the following. So the LCD would be 6y and 4y plus 12. So we could factor this into, pull the 4 out, and you have y plus 3. And we could factor that again into 2 times 2 times y plus 3. And here, this is 2 times 3 times y. And now to find the LCD, the lowest common denominator, the smallest thing that both of these things will go into, we take what they have in common, and we take all the leftovers. So they only added 2 in common. And then that counts as a leftover, that counts as a leftover, that counts as a leftover, and this counts as a leftover. And so our LCD for this is, let's see, 612y times y plus 3. That's the LCD. Let's find it on number 2. So we have 4 over x squared plus 4x plus 3. And we have 4x minus 2 over x squared plus 10x plus 21. So we're going to want to factor this. Multiplies to be 3, adds to be 4. That's only 3 and 1. Right? Suspects for 3 are just 1 and 3. That's it. And that adds up to 4. For 21, it's 7 and 3. That'll add up to 10. And so when we look at that, if we stack them up like this, x plus 1, x plus 3, x plus 7, x plus 3, to find the LCD, you find what they have in common, so they have x plus 3 in common, and then you take the leftovers. So both of those count as leftovers, x plus 1 and x plus 7. So that is my LCD, x plus 3, x plus 1, x plus 7. All right. Then let's take a look at, okay, just want to make sure you could see it. You can. Let's take a look at the next couple of problems. So we're still finding the LCD. Number 3 and number 4. Number 3, x over 5x squared minus 5 and 4x squared, x squared minus 2x plus 1. So this, I can pull a 5 out, get x squared minus 1, and then I can factor the difference of two perfect squares. So xx plus minus 1, 1. Here, I can multiply as v1 adds to be negative 2. That's got to be minus 1, minus 1. So, if we stack them up next to each other in factored form, the LCD, we take what they have in common, and then all the leftovers. And even though we took this as a match, we also take that as a leftover. So our LCD for this problem is 5 times x plus 1 times x minus 1. And now if you wanted to, you could put a little squared there, fancy, or you could just leave it x minus 1. All right, and then the last one, 4, is find the LCD with 1, x minus 3, and 2, 3 minus x. Okay, so this one's a little silly. This is, just leave it like that. This is, let's write it like this. Let's put the x first, then the 3 second. You know they're up to shenanigans when they have the variable second. And now if we multiply top and bottom by negative 1, we end up with 1 over x minus 3. You distribute it, it's negative 2 over x minus 3. So the LCD there was hiding in plain sight. It was just x minus 3. We just had to rearrange it a little bit and re-express it. Okay? So, let's see. I don't want to run out of time. Tell you what, we'll do one more. We'll do this last one, and then we'll call this part 1. And then I'll do a part 2 video. So last one, 3 over 9y to the 5th is equal to what? 72y to the 9th. Ooh. All right, so basically what you do here is you ask yourself, what do I multiply 9 by to get 72? And what do I multiply y to the 5th by to get y to the 9th? So 9 times 8 is 72, so I have to multiply that by 8. And y5 to y9, I'm missing 4 of them. So on the top, I have 3 times 8y to the 4th, which is 24y to the 4th. That was actually a little easier. I don't know if I had to erase the whole board. So that's 6.2 part 1. We'll do a 6.2 part 2.